Welcome to this explainer. Today, we're taking abstract math and turning it into a super practical tool. We're talking equivalent ratios. By the end of our time together, you're going to see how this one simple concept can help you navigate everyday decisions with absolute precision. Let's jump right in.
So, have you ever wondered how to perfectly scale up a batch of lemonade for a summer party without, totally ruining the flavor? Or maybe how to estimate a crowd at a local event without just completely guessing? These are real, everyday scenarios that can easily trip us up. But what if I told you there's actually a foolproof, incredibly simple mathematical key that unlocks the whole shebang?
It all comes down to the equivalent ratios rule. Here it is. Whatever you multiply or divide one part of a ratio by, you absolutely must do the exact same thing to the other part. It's really just a simple principle of balance. If you respect this one golden rule, the math will literally never let you down. Keep this tucked in the back of your mind as we move forward, because it's the engine driving everything we're doing today.
All right, Section 1, Scaling Up Your Snacks. Let's start with a low-stakes scenario right in the kitchen. We're going to take a look at Seif's box of muffins.
So Seif's box has a base ratio of 1 banana muffin for every 3 chocolate muffins. That is the fundamental relationship here. For every single banana muffin you pull out of that box, expect 3 chocolate ones right alongside it.
Now let's say we get a new piece of information. There are actually 2 banana muffins in the box, not just one. To scale this up, we compare what we know. Our base is 1 banana muffin, but we actually have 2, right? So to get from 1 to 2, we just multiply by 2. That number, 2, becomes our magic scaling factor.
Applying our golden rule, what we do to one side, we absolutely must do to the other. Since we multiply the banana side by 2, we have to multiply the chocolate side's base of 3 by 2 as well. And that gives us 6. Boom! We've seamlessly scaled our ratio up to 2 banana muffins and 6 chocolate muffins. The balance is perfectly maintained.
Finally, let's look at the total. Adding our 2 banana muffins and our newly calculated 6 chocolate muffins together, we get a grand total of 8 muffins in the box. Think about that. We just solved a real-world inventory problem without having to physically open the box and count every single crumb. We just trusted the ratio.
Okay, let's see how this builds with another kitchen challenge. Imagine you're making lemonade with a strict, perfect-tasting lemon juice to sugar ratio of 4:1. That's 4 parts sour lemon to 1 part sweet sugar. If you mess up this balance, well, your lemonade is going to be incredibly bitter or just overwhelmingly sweet. No one wants that.
Now, if you've got thirsty guests and decide to step up to using 8 cups of lemon juice instead of 4, we need to find our multiplier. We just recognize that 4 times 2 equals 8. So, just like with the muffins, our scaling factor here is 2.
Following that exact same pattern, we obey the rule. We multiply the sugar side by that same factor of 2. So multiplying the original 1 part by 2 scales our recipe up to 2 cups of sugar.
The crucial takeaway here is that a perfectly scaled, delicious batch of lemonade using 8 cups of lemon juice requires exactly 2 cups of sugar. The flavor profile hasn't changed one bit, all because that underlying mathematical ratio remained completely intact. Pretty cool, right?
Moving right along to Section 2, Counting Crowds and Herds. Let's escalate things a bit and prove this rule works universally, whether we're dealing with baking ingredients or entire populations. Say you're at a local event, and the baseline ratio of men to women is 5:3. So for every 5 men walking through the door, there are 3 women. That's the established dynamic of our crowd.
But wait, we don't just have 5 men, we're told there are actually 30. To find our exact multiplier, we just divide the total number of men, 30, by our base ratio number of 5. 30 divided by 5 gives us 6. So 6 is our multiplier. And following the pattern, we apply that same factor of 6 to the women's side of the ratio. We multiply the base of 3 by 6, which gives us 18. The balance scales up perfectly from 5 to 3, all the way to 30 to 18.
This tells us there are exactly 18 women at the event. Notice how, without counting every single person in the room, we used equivalent ratios and just one known variable to accurately lock down the rest of the crowd size.
All right, let's take this logic out into the wild. We're observing a safari park, and our tracker tells us the ratio of giraffes to zebras roaming the plains is 4:7. That's 4 giraffes for every 7 zebras.
Looking through our binoculars, we actually count a herd of 28 zebras. To determine our multiplier, we divide those 28 actual zebras by our base ratio of 7 zebras. 28 divided by 7 unlocks a factor of 4. By now, you know exactly how this plays out. We respect the rule. We take our giraffe's baseline of 4 and multiply it by our newly discovered factor of 4, giving us 16. The baseline ratio translates perfectly into real-world numbers while maintaining the exact same relationship.
And with that, we can confidently say there are exactly 16 giraffes roaming the safari park alongside those 28 zebras. We literally just tracked wild animals using nothing but pure logic. How great is that?
That brings us to Section 3, the 5-step ratio playbook. Because whether we're counting chocolate muffins, balancing sugar in a pitcher of lemonade, sizing up a crowd, or tracking wild animals, the underlying mathematical pattern never changes. The strategy is identical every single time.
You can conquer absolutely any equivalent ratio problem in your daily life by following these 5 simple steps. First, read the ratio carefully to understand the baseline. Second, find which number actually changed in your real-world scenario. Third, calculate your multiplication or division factor. Fourth, apply that factor to all parts of the ratio. And fifth, write out your final answer. It is a completely foolproof system.
Once you've got this reliable framework locked in, you'll be fully prepared for what comes next. In our next explainer, we're going to dive in and tackle 3-part ratios and complex visual graphs, taking these foundational skills and applying them to even more dynamic, real-world situations.
Thanks for watching. Bye, students. Don't forget to subscribe for more math fun videos. See you in the next lesson.